Welcome to Mastering Solutions. In this question, we're going to use two equations to solve for this. Let's make a list of everything that we have though, and then we'll work our way through this. We're told that the magnification for this is going to be 4 times. And we know that the lid is 12 centimeters from the bottom. So we're going to set that as our object distance. So S is equal to 0.12 meters, or 12 times 10 to the negative 2 meters. So same thing for these two. Now the two equations that we're going to use is the magnification equation, which we know magnification is equal to h prime, or the image height over the object height, which is equal to negative image distance over object distance. We're going to ignore the heights and just use magnification is equal to negative image distance over object distance. If we rearrange this to solve for the s prime, we'll multiply both sides by s, and then we'll say negative s, so that will get rid of that as well. So s prime is equal to negative magnification times the object distance. So since we have this, now we can go to the thin lens equation, which 1 over f is equal to 1 over s plus 1 over s prime. And now we'll take this here and plug it into the thin lens equation. Because what is it that we're trying to solve for, right? They want to know what's the focal length of the lens. So that's our goal. And so now we can use this, like we obviously can see here, to figure that out. So 1 over f is going to be 1 over the object distance, which we said was 0.12 meters. And now we're going to add to that 1 over s prime, but we're going to plug in negative m times s. So we have negative m, which we said was 4 times the object distance, which is 0.12 meters. So we have 1 divided by 0.12 plus 1 divided by negative, let's put some parentheses here, negative 4 times 0.12. So that gives us 6.25. So 1 over f is equal to 6 1/4 diopters, but we want the focal length. So let's change this to just f by taking the inverse of that. So 1 over 6.25 is going to be equal to 0.16 meters or 16 centimeters. So with a positive value in diopters, that means we have a converging lens, and the lens with this power will give us a magnification of 4 times with this distance, but the focal length is 16 centimeters, which makes sense that since the object is closer to the lens than the focal point, we'll get a virtual image which will magnify it.